It's in the section of multicollinearity. What is perfect multicollinearity? No perfect collinearity assumption fails when we include two measurements for the same variable. For example, years of education and months of education. Why is that? Because months of education is a linear transformation of years of education. You may want to review the examples for perfect collinearity. One regressor is a linear combination of other regressors. So linear combination, if it's multiplied by a constant, if the regressor is multiplied by a constant, or if it's a substitution. What is not linear? For example, x1 is equal to x2 times x3. This is a product. This is not plus or minus or multiplied by a constant. If it's a product, then it's not linear combination. Or, for example, x sub 1 is equal to x sub 2, or x squared sub 2. This is a quadratic form, so it's not plus or minus or multiplied by a constant. Example 3, you can come up with a lot of nonlinear forms, natural logs, or x sub 1 equals x sub 3 plus log of x sub 4. It's not perfect collinearity. If we go back to the question here, it says, we regress log of wage on education and education squared, since education squared is a deterministic function of education. We have perfect collinearity. As we mentioned here, if it's in a quadratic form, then it is not linear. So we do not have perfect collinearity. Perfect collinearity occurs when an independent variable is a linear combination of other independent variables in the regression. Since education squared is not a linear function of education, unless education takes only two values, we do not have perfect collinearity. Part C, in the multiple regression, we cannot include two regressors, say x sub 1 and x sub 2, if x sub 1 represents the years of education and x sub 2 represents the months of education. This is true because this is a linear combination. So in this case, it's an independent variable multiplied by a constant, so it's linear. It's linear. We have perfect collinearity. In part D, suppose we want to regress earnings on college, where college only takes only two values. Suppose the correlation coefficient between college and earnings is 0.5 in a dataset. It implies that the zero conditional mean assumption is unlikely to be true. So in the answer, it says that false. The zero conditional mean assumption states that the conditional expectation should be equal to 0. And the simple correlation between earnings and college does not give us any information about the conditional mean of the error term. This is the big E open bracket U sub I given college sub I close bracket equals 0. This one is kind of like part A. In part A, the question gives us something that has nothing to do with zero conditional mean. But of course it is false. In part D, the question is giving you something that has nothing to do with the zero conditional mean assumption. Sometimes you should know whether the concept given in the question has something to do or does not have something to do with something. Sometimes it could be completely irrelevant. But if we go back to the question, in which cases is the zero conditional mean assumption unlikely to be true? We have to talk about omitted variable bias, which should not be omitted. Then it's a zero conditional mean does not hold.